Well, hey, engineering students, if you're needing a quick refresh on how to leverage the power of Google Sheets to help us with some of this data, go ahead and click in the box for I3 here, right next to the mean. And to start a formula, we start by typing equals. And then another word for mean is average. So if I start typing AV for average, I get quite a few options here. So average, numerical average in a data set, ignoring text. Yeah, that's exactly the average that I want. So you can click and highlight the IV numerical data, or you could click the B at the top, which is just that entire column, and it will ignore the text because that's what it said it would do. So press enter and you'll find that the average for this original data was in fact 23. For the sample standard deviation, since this is just a sampling of 50 rolls from this manufacturing company, let's go ahead and type equals just to get a formula started. And then we want a standard deviation. So if I start typing ST, I have a lot of options that pop up. And specifically, I do want the standard deviation .s because this is going to find it for the sample. It's a slightly different formula than what we would use if we were finding the entire population, like we had every single roll ever. Let's go ahead and click that. And this one didn't say anything about text, but I'm going to click in cell B2 and click and hold and drag all the way down through all of the IV data here, and then press enter. So the sample standard deviation is 1.76. We don't really have anything to compare that with until we get to the next part of the assignment. So, okay, that's just our sample standard deviation. If it's a high number, it means the data is really spread out. If it's a lower number, it means it's a lot more confined around the average or the mean. But we don't know if it's high or low until we have something to compare it with. All right. Then next up, we have a listing here of an IV metric, number of jumbo rolls, and probability. So if I'm curious about some of this data, I need to know how many times does the number 22 show up in this list of data, right? So there are probably lots of ways to do that. I'm going to click in B and just highlight that whole column and go up to data and sort this range just from A to Z, also known as low to high if it's numerical, right? So IV, the label moved, but that's fine. So what I'm seeing here is I see the IV metric 19 as my lowest possible IV number, and the number of times that appears is just one time. Next up is 20, obviously, right, because it's low to high, and there are three 20s in this list. For 21, right, I can manually count 1, 2, 3, 4, 5, 6. There are 6 times where 21 is listed as the IV metric. 22s, right, the more there are, the more annoyed I am to try to have to count this manually. So if I come over here to the bottom right, it's showing me the sum, but if I click on that, I can make it tell me something else, like the count. How many cells have I highlighted? 9 of them. So 22, there are 9 jumbo rolls. Let's highlight all the 23s. Okay. So make sure to get the first through the last highlighted. There are 12 23s that appear in this list. 24s, not as many, just 9 of them. Let's see, 25s, 6 of them. Okay, so this is really evenly spread out. 26s, okay, yeah, I can see there are 3 of those. And then there's 3 of those rather, and then the 27s, there was 1. Okay, so I mean, I see this, I can see the numbers increasing and then decreasing right around our average. So that all checks out. If I want to calculate like the probability, like what's the likelihood that our machines are going to kick out a roll with an IV metric of 19, I'm going to type equals to start my formula. I'm going to click in the numerical box here, which is E4, and hit divide by 50. And so I'm going to press enter, and that's going to give me the probability of getting a jumbo roll with an IV metric of 19. And then I'm going to go ahead and click yes, the check mark for this auto-filling formula, because this box then went down a row, and it's taking the E5 number divided by 50. This one is taking the E6 number divided by 50. So it's perfectly finding all of my probabilities for each row. So that way I can see that, okay, between 21 to 25, right, if I want this to actually sum this up now, let's switch back to sum. It's 0.84. It's 84% of all of this sample does fit the requirements for this company who wants the really high quality stuff. So 84% is pretty good, but that does mean that 16% is falling outside of their specs just for this one metric. Okay, so the last thing we did in class was to create a chart. So I'm going to click on and highlight my IV metric and the jumbo rolls. And we could have done this from the original data, except now it's kind of scrambled. So I'm going to include those labels and insert chart, because the first type of chart it tries to insert is a column or bar chart. And it has the title, jumbo rolls versus IV metric. And I can see the exact numbers along the bottom. I can see the exact count of how many there were. And so sure, here's my average 23, and I can see how things fall around it. It looks pretty normally distributed, right? It's not skewed off to one side or anything. But what I really want to compare with is that test data, right? So after they made some changes and they're testing something out, does the data improve? Does it get better or closer together between 21 to 25? So that's kind of the plan for the next day of class. So hopefully this helps you, especially if you just need a quick refresh on how to make these formulas happen.